call Vijara. I think he is calling.
Good afternoon, everyone. On behalf of Ocean Society of India Pune chapter, I, Dr. Aditi Deshpande, welcome you all to World Ocean Day 2023 seminar. I thank you all for gracing us with your presence. Oceans Day was declared as 8th June 1992 in Rio de Janeiro at the Global Forum. The declaration was inspired by an event organized on that day by the Oceans Institute of Canada and supported by the Canadian government. In 2008, led by the Canada General Assembly, the General Assembly resolved that 8th June would be designated by the United Nations as World Oceans Day. World Ocean Day reminds every one of us the major role the oceans play in our everyday life. They are the lungs of our planet, a major source of food and medicine, and a critical part of the biosphere. The purpose of the day is to inform the public of the impact of human actions on the ocean, develop a worldwide movement of citizens for the ocean, and mobilize and unite the world's population on a project for the sustainable management of the world's oceans. Planet Ocean, Tides Are Changing is the theme for World Oceans Day 2023. The UN is joining forces with decision makers, indigenous leaders, scientists, private sector executives, civil society, celebrities, and youth activists to put the ocean first. To commemorate this year's Ocean Day, we have lined up 2 lectures by notable scientists, Dr. Rajiv Nigam and Dr. Vino Valsala. Before we start, I would like to request Director IITM, Dr. R. Krishnan, to give his opening remarks on this occasion.
Good afternoon to everyone. Thank you, Dr. Aditi Deshpande. Dear esteemed guests, colleagues from IITM and the Ocean Society of India Pune chapter, and our esteemed speakers today, Dr. Rajiv Nigam and Dr. Vino Valsala, and many of our colleagues, Dr. Anant Parekh, Dr. Anant Parekh, Supriyo Chakravarti, Aditi Deshpande, Bhupendra Singh Bahadur, and several others. First of all, I want to thank all of you for organizing this event on the important occasion of the World Ocean Day program. And I would like to congratulate Pune chapter for this. And first of all, I would like to welcome all of you to this important event of the World Ocean Day 2023 celebration by the hearty welcome to all of you. I'm very happy to see that today's lectures, there are 2 very important lectures by Dr. Rajiv Nigam, a good old friend of mine. And it's very nice to know that he is going to talk about the understanding fate of many ancient Indian coastal towns through geological and paleontological records, and Dr. Vino Valsala on the ocean acidification as a threat to marine living resources. And as Aditi has nicely brought out, oceans are covering more than 70% of the Earth's, and they're an integral part of the Earth. Moisture for precipitation and for the monsoons, the Indian monsoon and several regional monsoons, and one role in sustaining life and biodiversity. So today, climate change has been human-induced activities through climate. It has altered the climate system. It is already affecting every region on the Earth, and the temperature has increased by more than close to 1.2 degrees. Since pre-industrial time, and mainly because of the human activities, the oceans have warmed up globally. Indian Ocean is one of the largest, warming at a very fast rate. So due to the thermal expansion, sea level rise has been happening. Also due to the addition of mass due to the melting of the glaciers and the land ice, sea level is increasing. There is also the issue of ocean acidification. Corals are being endangered. And there's issue of marine pollution. the ocean resources, and it's important for us to conserve the ocean, sustain the biodiversity we need. And this is current decade the UN has declared as the decade of ocean science for sustainable development. This is through international cooperation, through science and technological development. We should develop new innovative ways of conserving and protecting our oceans. With these few words, I would like to welcome you all once, and I'm looking forward to the talks. Actually, I'm right now in Delhi. I have to quickly hurry to the airport, and Dr. Rajiv Nigam's talk. I may have to leave in between, so please excuse me, sir. And with these few words, I welcome you all once again and congratulate the OSI Pune chapter. Thank you very much once again. Jai Hind.
Thank you so much, Dr. Krishnan, for taking time out of your busy schedule and for your encouraging words. We will now begin our seminars with a talk by Dr. Rajiv Nigam. A few words about him. Dr. Rajiv Nigam is an emeritus scientist, former head of Geological Oceanography Division and head Marine Archaeology Unit at National Institute of Oceanography. Dr. Nigam completed his MSc in Geology from Lucknow University, Diploma in Marine Micropaleontology from Oslo University, Norway, and a PhD DSc in Geology from Aligarh University. His areas of interest include marine geology, micropaleontology, paleoclimate, sea level changes, paleomonsoon, marine archaeology, pollution studies, paleofisheries, coastal surveys for industries. Dr. Nigam has over 160 scientific research papers, has edited 8 books, and has authored 37 technical reports, adding up to more than 3,400 citations, and an H factor of 31 and an I factor of greater than 110. He has also contributed to 33 popular articles in Hindi and 16 radio talks. He has worked on several capacity building events and capacity building modules and is a member of several associations and boards. The title of Dr. Nigam's talk today is Understanding the Fate of Many Ancient Indian Coastal Towns Through Geological Paleontological Tools. I request Dr. Nigam to please present his talk. Thank you.
You are muted. Sir, you are muted.
Dr. Nigam, if you can hear us, you're muted. You need to unmute yourself.
So I will share my screen first, Aditi, and when you can see, you can say you can start. Okay. Yes, please. Okay, can you see the screen? Yes. Hello?
Yes, sir, we can see it, sir.
Okay. Welcome to you all for this Ocean Day seminar. And for me, it's a great opportunity to talk about cultural heritage in the city which is considered to be the cultural heritage of Maharashtra. Today, I will be talking about understanding the fate of many ancient coastal towns through geological and paleontological tools. On the screen, you can see this is from Dwarika, this is our Anayo, this is a depiction of famous local dockyard, and this is mainly our paleontology tools. In today's talk, Mostly, I will be talking about the oldest dockyard, that is the Lothal. I'll be talking about Dhalavira. I'll be covering the submerged Dwarika, maybe Ram Setu, or if possible, the ancient city of Surat at 30 to 40-meter water depth. Let us see how much I can cover in the given time. And I will be using mostly the geology and paleontological tools. Friends, this is a question which has been repeatedly asked in an IO and elsewhere. Why to study marine archaeology, that too in a scientific institution? It should go to the art side or archaeology departments only. I will try to answer that. And whether it is of academic interest or it is of a cultural heritage or it is the economics or a combination of all. Friends, I feel that it is a combination of all. It is of academic interest to know where are our roots, what our ancestors have done, what is our cultural heritage, and whether this is only of academic and cultural importance or there is any hard economics behind it. Actually, the archaeology many times has been linked to the tourism. And if you see, the tourism is a big industry now all over the world. If you go to any foreign country, whether you go to China, see the Great Wall, or you go to see the Statue of Liberty, or you go to Switzerland or Italy, or you go to England and see the fort there, none of them are more than roughly 2,000 years old. But they are earning billions and billions of money because of tourism. If you see in our country, we have a very old history. We have a long cultural heritage, not only within country. The Indians has gone abroad. You see the world's largest religious structure on the earth is in Cambodia, built by a Indian Tamil king, Suryavarman, at Angkor Wat. Lebanon's Baalbek temple also was built by the Indians. But how many of us were knowing that this belongs to us? Before it came on the 100 rupee note, how many of us were knowing the importance of this step wells of Queen's step wells or the Rani Chiva in Gujarat? See, when we don't know our own cultural heritage, how we can tell foreigners you come and see and spend with us in your foreign currency? If you see here, I just tried to pick up the data. It was not available for recent years, but if you see here, most of the foreign exchange has been increasing from 2016 to 2019, you can see, and earning of the archaeological monuments are confined to in and around the Delhi. Taj Mahal, Qutub Minar, Agra Fort, Humayun Town, Red Fort, and Fatehpur Sikri. They are the one who's, because our priorities has not been set right. See, the Mughal period or monuments are excellent. I'm not against them, but we have much more older monuments and which can definitely attract the foreigners. Even places like Mahabalipuram, Konark, Khajuraho, Ellora, Hampi, they are actually contributing very little to the our tourism income. So there is a need that first we should know what is our cultural heritage, and then only you can tell to the foreigners. How many of us know that world's oldest dockyard is within our country? How many of us oldest evidence of tsunami protection measures are in our country? And they are about more than 4,000, 5,000, 6,000 years old. So let us go to the journey. And the second question, how the science See, just by a literary evidence that Lord Krishna built the Dwarka is not going to convince anybody. So for our region, we have to see that what the science can contribute into the authenticity of our monuments. See, the things have started changing. If you see in the budget speech, our finance minister Nirmala Sitharaman has mentioned that the government is going to promote the Rakhi Gadi, Dholavira and Lothal. And she told that ये तीनों जगह सिर्फ जमीन के टुकड़े नहीं बल्कि एक ऐसी संस्कृत फली फूली है जो भारत के गौरवमय गाथा का हिस्सा बन गई. See, out of these three places which has been picked up by the government for further enhancement in the budget allocation and research work is Rakhi Gadi is near Delhi, Dholavira and Lothal are on the coastal areas. For us at oceanography, we are concerned with the Dholavira and Lothal, we have contributed. I will bring it to your notice what science can do in the archaeology. Later, and the Prime Minister also added that we will bring back the glory of Dholavira and Lothal. The study of the archaeological monuments along the coast of India, where sea has played a dominant role, that became under the purview of the subject marine archaeology, which where the sea has played a role that comes under the marine archaeology. It is rather a new branch in the oceanography. The marine archaeology in India was started by late Dr. S.R. Rao in 1981. Friends, this is a very classical example what a retired people can do. Many of the retired people think that after 60 their career has come to an end, or others made them to feel that you are good for nothing anymore. Dr. S.R. Rao, after retiring from Archaeological Survey of India, came to NIO and started the marine archaeology. And hats off to the scientific leadership of CSI at that time. Dr. Qasim, Dr. Siddiqui, Dr. B.N. Desai, all these people, Dr. Vardachari, they encouraged him and he started. Initially, he started with the Pombhar, and because of the logistic things, he has shifted to the Dwarika. And he came alone. He came and chose NIO because anything connected to the ocean, you can get all the branches of science, whether it is geology, biology, physics, chemistry, instrumentation, survey, everything is below one roof. So, and based, finally, he succeeded with that. He started with the INSA project of 20,000 rupees. And based, he brought a big name and fame to NIO due to his monumental work on submerged Dwarka. I will discuss it a little later. And finally, a unit was established in NIO in 1991. You can see this is our team and we are on the survey. When Aditi was introducing me, she told that I'm a student of geology, then what I am doing in archaeology. It's very interesting how I came in. See, archaeology may be subtly defined as a systematic study of antiquity as a means to reconstruct the past. So the basic objective of archaeology is to reconstruct the past, and as a geologist, we also reconstruct the past using the marine sediment. They use something like the coins, the anchors, the wells, the remnants of the past life monument. So these are their tools. And we use the marine survey, geophysical instruments, geological instruments, marine fossils as a tool. So when two branches of science are having a common objective to reconstruct the past, there has to be some parallel and they can support to each other. Since I was involved in reconstructing the past climate with reference to the global warming problem, I found myself interested in marine archaeology, and under the influence of Dr. Rao, I started reinterpreting my data with reference to the marine archaeology. Let us know first how we do reconstruction of past climate based on the marine sediment. If this is a land and this is the ocean, see Ocean receive the sediment from land by either rivers or by air. In addition to that, there are a lot of microorganisms also living into the water, and after their death, their hard part, the sediment and the hard part started getting at the bottom of the sea, layer by layer, year by year, and these fossils contained the environmental parameter of the ambient water when they were living. So we can take a ship, we can collect a core, and we can study these layers. So we can know what type of climate was there in the past, and we can put a radiocarbon date also, so we can talk with reference to the time. So this is the basic of reconstruction of past climates based on the marine sediments. And the mainly tool which we use is the microfossils. We use the microfossils because the fauna always amplify the climate effect. So foraminifera are exclusively marine organisms. They are very sensitive to the any climate change. There are two types of foraminifera. That is the one which live in the water column is known as planktonic, and the benthic which live at the bottom of the sea. After their death, they both settle at the bottom and provide us a clue about the past. So as I told you, they are exclusively marine organisms. They are sensitive to the climate change. They are having a very good depth stratification, and a slight change in the environment. There is a big change in the foraminiferal population. There are more than 40,000 species of foraminifera are there, and worldwide they have been used extensively for reconstructing the past climate. Just to show how they look like, look at each one is less than a millimeter in size. Okay, these are the ones which live at the bottom, and these are the ones which live in the water column. In China, they have been the designing of this more than 40,000 species that have been used to develop a park where the foraminifera models are there in granite. They have been also used for commercial applications, and they have been used to solve the variety of problems in the marine environment. It is paleoclimate, sediment transport, which is an engineering application. Petroleum exploration is an age-old application. Monsoon variation, this was the first thing on which I got my award, Young Scientist Award. We can reconstruct the past monsoon records. They are applicable in fisheries, commercial application already I told. You can also get an idea about past tsunamis, past sea level changes, pollution monitoring, and marine archaeology. Today, I will be discussing only the sea level changes and the marine archaeology. How these foraminifera are useful in marine archaeology, let us start. After the partition of India and Pakistan, the classical archaeological site of Mohenjo-daro and Harappa we lost to Pakistan. And there was efforts by Indian archaeologists to discover new sites within our territories. One such excavation was done in 1954 at Lothal by Dr. S.R. Rao when he was in the Archaeological Survey of India. See, the Lothal is 12 kilometers away from the sea, few meters above the present sea level. There was a mound, and when Dr. Rao excavated, it became a big news of that time. Lot of publicity was given because Harappan town has been discovered at Lothal, and lot of you can see the lot of structures have been excavated. Lot of seals, Harappan seals, you can see. This is the wharf at Lothal, and this is a burial ground, and then you can see. But along with all these things, you can see here a big tank-like body. And this made a big sensation. And from here, the marine archaeology started. How? The purpose of this dockyard, soon after its discovery, was debated. One group of archaeologists were telling it's a tidal dockyard. Okay? And this is a artistic exhibition that how a dockyard was there, and this was the city. But the other schools say no, it was not a dockyard, and it was a freshwater storage tank. And friends, can you believe that this controversy was continued for about 40 years? How they were arguing. See, they excavated few stones, like this. You can see those stones type things here. One group of archaeologists led by Dr. Rao, supported by British archaeologist Martin Wheeler and many others, that these stones were used as an anchor stone and therefore this was a dockyard because boats used to come. Even now you can see some of the boat people are using this stone as an anchor. Same stone, it is the other group led by the Deccan College director, Professor Sankalia. He says it is a counterweight to lift the water for irrigation. You can see here still. This is the counterweight. And supported by the British archaeologists like Leshnik, Surveys, and many others. And there are many arguments, there are many objectives. I picked up a very simple argument. And this shows that where science come into the picture along with the archaeologists. One group say it is a dockyard, the other group say it is a freshwater storage tank. What I did, I collected the samples from there. Okay. And when I analyzed in my lab, actually, PRL took me to this site first. And when I came to know about this problem, I thought as a geologist, we can contribute very easily to solve this controversy. Why it is on for 40 years. And we found a well-preserved foraminiferal population, which can be seen equivalent to the Assyrian population. So it means this tank-like body was filled with the marine water, and therefore it cannot be irrigation tank. And this has tilted the argument in favor of the dockyard theory. This became first time when I presented it to the International Archaeological Conference. It became a very popular paper. But some question, though this finding of foraminifera in this tank-like body tilted the argument in favor of dockyard, but still has to answer some questions. If it is a dockyard, what it is doing 12 kilometers away from the sea and few meters above the present sea level? Unless sea level was higher than today, it cannot be a dockyard. It means we need a knowledge of the sea level. And it was not available to the archaeologists. That's why they kept arguing with each other for 40 years. Had they consulted, then geologists or paleontologists who could have been solved that time. What we know about sea level changes. Normally, in our school days, I remember we were taught that Samudra apni maryada nahi to hota. Sea never crossed its limit. Our Prime Minister, when he visited Mahabalipuram temple along with the Chinese Prime Minister, he wrote a poem, and one line was there. He sagar tumhe mera pranam, tum kabhi na apni सीमाएं लांगे. Artistically, it's a fundamental, excellent line, but geologically, it's not true. Sea has always crossed its limits. A lot of studies are going on for sea level changes. Even we were doing initially the studies with reference to the global warming, because one of the objective of the global warming studies is to study the accelerated rise in sea level. So unless we know the past sea level conditions, we cannot accurately assess the influence of man on the sea level rise. Professor Krishnan also mentioned about likelihood of sea level rise, that I will discuss some other time. But what was the condition of natural climatic variability as far as sea level is concerned? The records of sea levels are available everywhere. In religious records, whether it's a Gita, whether it's a Quran, or in the Bible, the story of Noah's Ark is very famous. Hazrat Manu was building an ark or a boat in a desert area. Unless somebody have a knowledge of future sea level rise, he will never do that one. As a geologist, we know sea level has fluctuated. Where the mighty Himalaya stands today, once long back, about 50 million years back, that is sea was there. So where the highest mountain stands today, once upon a time, that was the sea. Lot of the east coast was under to the sea. The Cretaceous translation is very famous. Even Surat and Bharuch area, we have a Miocene outcome, marine exposures there. One branch of sea was there up to the Madhya Pradesh. But where we are interested, where a human or mankind is interested, is the Holocene sea level fluctuations. So there are many sea level curves proposed. This is relative sea level curves. Means the rise of sea level because of thermal expansion, but because of melting of ice and the relative position of tectonic activity. So this is the final sea level curve. Since you can see every area have a different curve. So whatever has been done by many foreigners, we cannot apply in toto in our area. So we started building the curve for our area. The higher sea stand signatures are available in form of notches and sea caves, and there is no sea now. The sediment eroded from these areas, deposited at some other places, which you can see ancient beaches. You can date them and you can tell that when sea level was higher than today. When sea level was lower than today, so let us see that if this is the figure done by Rajni Panchang, she's from Pune University. See, the fauna which is living in the balance with the depth and depth indicator species, they kept moving with the rise in sea level. And the time comes when they cannot keep the pace with the rise in sea level and became extinct. So you can date them because they're carbonates. So this will be the oldest, this will be the youngest. So depth versus date, if you plot, you can get a sea level curve. That's what we did. Whatever was published first time in 1995 and later we modified it in 2002 and 2012. And this is the sea level records. Holocene sea level curve. See, around 15,000 years back, sea level was lower than 100 meter as compared to the present sea level. Can you imagine that? Miles and miles area must be exposed, which is now under the sea. It started rising and around 10,000 years, quite flat, it was going very slowly. Then a very sharp rise is there. Then again a slow rise. And around 7,000 years, it has crossed the present sea level. Then it was higher than today. It came back again around 3,500 and then again got up around 2,200 and then almost on the present level. Now, this sea level curve became like a magic lamp to explain many of the archaeological findings, how the fate of coastal cities have changed with reference to the change in the sea level. I was talking to you some time back about Lothal. Whether around 4,500 years back, sea level was higher. And if Lothal was a dockyard, friends, it is as claimed by archaeologists, this turned out to be the world's oldest dockyard ever discovered that is in our territory. Let us see, around 4,500 years back, which is the age of Lothal, there was the sea. Sea level was higher than today. So it has proved that the world's oldest dockyard at Lothal we have in India, and we must be very proud of it. This is, and think that if it can be developed well, how much it can earn the currency through tourism. The world's oldest dockyard, which is still you can go and see in a quite good condition. Government of India now is developing an about 300-acre land around it, the National Heritage Maritime Museum at Lothal. Sometime I request all of you, please go and see this. You must be very proud of our long cultural heritage. The other place which is associated with the higher sea stand was Dholavira. Recently, Dholavira has been declared as a World Heritage by UNESCO. You can see these are the many of the structures. If you go at Dholavira in Gujarat, you can see it. And because now it is developed as a World Cultural Heritage, it's becoming more popular. This was also, according to us, this was a port town because it is around 5,000 years, and 5,000 years sea was much closer to it. And this was used as a seaport town. But it was not famous for that. It was famous for, you can see this is a side plan of the city. It is between the two minor rivers, Manhar and Mansar, these two rivers, very minor rivers. And these are the excellent rainwater harvesting. So excellent water conservation system, this was world known. This was first noticed by Dr. Jagatpati Joshi, who first notices, and Dr. Bisht has excavated it from 90 to 2005. And for this work, he was awarded a Padam Shri. But we are bringing and trying to project it as at the site for another reason. You can see here a wall. This is a 18-meter thick wall, the citadel area. And the city was also fortified the wall. Why one has to build a 18-meter thick wall? 18-meter thick wall. When Dr. Bish delivered a lecture, I asked him, he says, must be for the protection. So my next question was there, protection against whom? Animals. For that, even a bamboo wall will be enough. For enemy, see, the forts which were built after the gunpowder was discovered. None of them are having this much thick wall. Even China wall is not that thick. Then why they built a 18-meter thick wall? And it cannot be because of flood, because the rivers are very minor rivers, seasonal rivers. That's why they developed the world famous water conservation system. So according to us, this area is, we published this paper in Geomarine Letters, me and Subodh Chaturvedi, that this area is the Makran coast is a tsunami prone area. And we already noticed a 8,000-year-old tsunami. So this could be a tsunami protection measure because they knew that this is a tsunami prone area, but still they have to build a city because of its strategic location. So they develop a device of fortifying this entire area with a thick wall, 18-meter thick wall. We published that paper. See, Dr. Dr. Valdi also given another explanation. He thought that see, the western wall, the northern gate, what I showed you, eastern gate, the northern gate, this is having a tilt wall, which is reinforced. According to him, this indicates that Lothal was probably destroyed by the earthquake. Friends, when earthquake comes, it hits from the bottom, and therefore the chance of collapsing is more. Whereas tsunami hit from the horizontally, so chances of tilting is more. This is another indication that this area was tsunami prone area, and ancient Indians developed a city or a thick wall, and which is the first and the oldest, world's oldest evidence that ancient Indians were aware of tsunami protection measures, things for which we must be very proud of it. Then we again thought of it, let us do some surveys whether there are any indication of the tsunami in that area. So we did the GPR survey, which is basically used for civil engineering. We used here in Middletown. See, we got about 2.5 or 3 meter thick sediments, subsurface sediments, which is not having any layer. Friends, when the sediment deposit, whether it is a river or whether it is a sand dune or whether it is a marine sediment, everywhere you can see the layerings. But if you take a truckload of sand and dump it anywhere, it will not have any layer. So one-time thick deposit, it is possible only under two conditions, either the flood or the tsunami. If it comes from the seaside, it will have a tsunami. If it comes from land side, it is the flood. So we did a trench. He is Dr. Lawson, who has done a GPR survey. He is a very well-known expert in GPR survey, and it's Rupal Dubey, got a Young Scientist Award. And she is the one who did this geological work in this area. And when we did the sampling from this layer, we all got foraminifera, which indicate that this is not the flood sediment. It means tsunami came into this area and destroyed. It became one of the reasons probably for the destruction of such a flourishing city of Dholavira. Now, these two examples tell you what happened to the city when the sea level go down. Okay, so the city which was flourishing, they became out of use because sea level has gone down. I will give you a few examples when sea level will go up, what happened. This is the Dwarka, and just near to the main Dwarkadish temple, you can see Dr. Asara excavated. There was a Panchayat house. Below that, you can see ancient city. With this, Dr. Asaro developed an idea that probably, as per the description in Mahabharata, the original city was built into the sea, and as the sea level keep going up, probably the city has been shifted, and therefore some of the ancient one is still buried into the sediment. With that idea, he thought of surveying into the offshore area, and you can see this is offshore for 20 years, and I've kept doing this survey, and they came up with a beautiful proof that the ancient city of Dwarka, which was also mentioned into Mahabharata as Krishna's Dwarka, is not the fig of imagination, but there is a hard proof that city did existed and engulfed by the sea later. And see,
Nigam,
yeah,
I'm sorry to interrupt. I request you to wind up in another 10 minutes if possible.
sure, definitely, definitely. So, see, it is mentioned into Mahabharata that city of Dwarka was built on a reclaimed land. You can reclaim the land if sea level is going down. You can see sea level was going down and city was built here. And when sea level has gone up, it became a submerged city. So this is a proof that ancient Dwarka is not imagination. Three reasons probably and other people have given, which may come into many interviews. Some people say it is because of erosion. See, erosion can erode the sediment of the beach and structures above can collapse, but it cannot inundate the city. Some people also came up with the idea about tsunami. This cannot be a tsunami because tsunami temporarily inundate area, but permanently it cannot submerge the city. So only the sea level rise and the sea level changes can inundate a city, and therefore Dwarka was uh, gone into the water because sea level has gone up in that area. This is also available on the YouTube. Recently at Sinoli, archaeological excavation has been done. I leave it to the archaeologists. If anyone is uh, logged on today, they can put a question or give an explanation later. See, they found weapons, something like no, the spear and a chariot. And this is 3,800, whereas Dwarka was 3,500 years before present. Whereas in Lothal, you don't get the weapons. It means the society from agriculture, agrarian society, agriculture-based society finally was turning out to be a warrior society. Means when more wealth is there, more city was developed, then there is a conflict, and when there is a conflict, a big war like Mahabharata did happen. So Sinhalli also fit into the story of the sea level changes and their relevance in marine archaeology. Another big controversy is there. This is about the Ram Setu. The area between India and Sri Lanka. It has been believed widely by the people that Rama's army has built a Setu to cross over to Sri Lanka. It became a big controversy uh, when there was a Setu Samudram project was conceived, and there used to the likelihood was of dredging in this area, and people were very much concerned. So some of the then government gave a affidavit that Ram Setu there is nothing like that, and it's an imagination. And later, when survey was done, and I was also asked the questions. But my question that time was there: what was the time maker of Rama? We were not knowing. So Saroj Bala and Kulbhushan, they organized a conference and they presented a paper. With the conference was organized, inaugurated by our former president Abdul Kalam Sahab. See what they have done. They have picked up the star positions from the Ramayanas and Sanskrit literature and set that position into the planetarium software, and they came up with the idea that Rama's time is something around 5,100 BC, means roughly 7,100 before present. And now we can play a role. See, around 7,000 years, sea level was about 2 to 3 meters lower than today. Therefore, and the depth between the water depth between India and Sri Lanka is almost about 3 meters. It means at the time of Rama, probably India and Sri Lanka were having a very, very shallow sea, except few ditches in between, which can be filled by the stones and whatnot. And you can create a bund. It's a causeway. It's not a flyover. with the word. That's why in Sanskrit it is called Setu Bandh Rameshwaram. It's a bandh. So the Ram Setu was not a figure of imagination, but it's a scientific studies indicated, yes, it was possible at that given time to cross over to Sri Lanka by creating a bandh. This also was covered by ZTV, Ashtak, and many other channels. How a science can help to decide whether this of the mythology or whether it was archaeology and whether it was true or not. And this is my last slide. Another, your sister organization, NIOT, in 2000, as a chance discovery, they found the world's oldest sea and it became a very controversial. Around 9.5 thousand years back, at 30 to 40 meter water depth of Surat, they found a remnant of ancient city. India today brought out a special issue. Outlook finally contested it. Now, it became controversial because nobody bothered to see the sea level condition at that given time. They were only discussing about the artifacts of that time. Now, see here. This curve was published long before. This discovery came later. And see, 9.5 thousand years back, sea level was between 30 to 40 meters. So no one should have any doubt that it is possible to have a sea at this given time because the river which are joining here was joining somewhere here at that time. So this is the world's oldest city, around 9.5 thousand years back, around between 30 to 40 meter water depth. It's also within Indian territory. Another reason for all of Indian to be very proud of that. And this controversy also settled with the help of sea level curve, which is done by the geology and the paleontology together. Friends, now I can say that when sea level was higher and gone lower, it has affected some of the seas. When sea level was lower and gone up later, it has also destroyed some of the coastal cities. Okay, now, you are sitting at the IITM, you all know that sea level is likely to go up. And I picked up a newspaper cutting, the Vinci underwater and Panjim next. A lot of our coastal cities are at risk. And if no precautionary measure has been taken to arrest the global warming, maybe after a few hundred years, the future archaeologists will start feasting on the modern day flourishing coastal cities all along our coast. Thank you very much. This is a small step to unravel the past in order to illuminate the future. And this is the reason why one should study the marine archaeology. Thank you.
Thank you for that exciting talk, Dr. Nigam. It's quite interesting to know how tools which are used in marine research can help us reconstruct the past, and learning the past can actually help us plan for a future. So we have time for one or two questions. If anyone has any questions, they may raise their hand.
Yes, okay. I can see.
Yeah, it's a very informative talk. The sea level rise which destroyed Dwarka according to geological evidences, do we find similar evidences from other parts of the world? Because sea level rise cannot be regional, right?
Yes. See, it's a very interesting question. The given time, what is the position in other places? Whether they were a developed civilization along the coastal area in other places. There are some, particularly in Gulf area, some of the ancient cities, the port towns have been discovered. Not only abroad. I think I will add to your question first before giving the answer. All the things, if you find except Ramset, everything was happening in Gujarat. Okay. What about rest of the coastal towns except the Pumphar? And Pumphar also has been put around 2000 years. No one else was living into the southern India. No, I don't think so. See what happened. We all follow very easy method to do the incremental research. Since SR, maybe as a chance or maybe a determined study, found a Lothal at Gujarat. After that, every archaeologist started going to the Gujarat and kept doing a incremental study. I also got now Dhalavira, I also got Padri, I got Shikapu. So many small towns people have reported it there. If you see Ram Setu is correct, if you believe in Ram Setu and story of Rama, he has not brought any army from Ayodhya. He built up the army in South India where they were living. They must be also having the city. Only three possibilities are there. Either there was no establishment, which is very unlikely. There were establishment and completely destroyed, and they have not left a iota of evidence anywhere, or we have not got into remote areas and no concentrated efforts have been taken. I think the third explanation is more logical extent. We did some survey in Cochin area and we found about more than 1,000-year-old fort there. In Goa, now we are started working and MOS has given us a project about Gopikapatnam. Nobody knew that Gopikapatnam was an ancient port, which is about when Chandor 2,000-year-old port. So what we have done is that we have just touched a tip of the iceberg. We need more people to come and start looking at scientific data and application of that into the marine archaeology. And with that intention, we started a training program at Deccan College, Pune, for the training in the diploma course in marine archaeology. But unfortunately, the Archaeological Survey of India tried to start a marine archaeology branch. Alok was trying it. Alok Tripathi could not do much. And now a lot of people retired, and I think we are left with only 2 archaeologists in NIO. There is a need for more science people into archaeologists. Okay, archaeologists we have many, but we don't have a science people in archaeology, training in the science and then application in archaeology.
Thank you. Thank you so much for the detailed answer. Yeah.
Okay.
Yeah.
Yes, Dr. Nigam, you very nicely explained about the possibilities of having tsunami threat to Dholavira, if I remember correctly. So, like the eastern coast of Indian subcontinent is more exposed to tsunamis because we have Andaman subduction zone, right? But what caused the potential threat over the Dholavira region? That is, I mean, one thing which is bothering me.
See, one thing is there, if you see the better, well-preserved remnants of ancient cities or ancient civilization on the west coast of India. I don't know, it was a natural thing because probably from the Sindhu, we started migrating towards the eastern side. And moreover, what example I have given today, because I myself has worked more on the west coast of India. Out of my 15 PhD students who completed, the last 2 we have done it on east coast of India. So since we have not used work on the east coast of India, I am not very confident to tell about east coast of India. Dr. Ramasamy of Bharatidasan, formerly he was at Bharatidasan University, he is doing a project on the Pumpar area. Okay. So the Pumpar is the best studied, you can say, or so far the best studied ancient port town. Otherwise, no work has been done. And that's why actually today I choose this topic, because this is the topic which connect us and provide the scientific evidence about the ancient cities, which were otherwise considered to be the mythology. Okay, and I hope that many more people will start using their tools. Geology, not only paleontology, there are many other branches. Even sedimentologists can contribute a lot toward the marine archaeology. Radio chemistry people can also contribute. Those who are working on a chronology with reference to the radiocarbon dates, they can also contribute to the marine archaeology. Actually, Dwarka samples were also dated by the radiocarbon method. We are trying to date the bones which we found at Dholavira to exactly get the real exact time when Dholavira was destroyed by the tsunami.
Thank you so much, Dr. Nigam. Do we have any questions from YouTube? I think not. Thank you so much, Dr. Nigam, for joining us today and for that extremely exciting talk. So we'll get on with the next talk, but before that, I'd like to give some information about the Ocean Society of India and the Pune chapter. The Ocean Society of India is a professional society that brings together people who are interested in or working on various aspects of ocean sciences, engineering, technology, and related fields. The society has life members from different parts of the country who are organized into local chapters in Kochi, Chennai, Pune, Goa, and Delhi. These chapters conduct regular activities such as seminars, workshops, lectures, and field visits to foster interaction and collaboration among the members. The main objective of OSI is to provide a platform for exchanging the latest scientific and technological developments in the ocean domain and to facilitate networking and partnership among the stakeholders. The society aims to inspire and motivate working professionals, researchers, and students to pursue excellence in their respective fields and to contribute to the advancement of ocean knowledge and innovation. The society also strives to empower the community to protect and manage oceans and their resources in a sustainable manner. The society organizes various educational programs, awareness campaigns, ocean conservation initiatives, success stories, and good practices to disseminate information and to raise public awareness about the importance and benefits of the ocean. The OSI is registered under the Societies Registration Act 1860 and has its registered office at the Center for Marine Living Resources and Ecology, CMLRE, Kochi. The society is governed by an executive committee elected by the general body of members, and it conducts national and international conferences, symposia, and exhibitions on relevant topics in ocean sciences, engineering, technology, and allied fields. The biennial conference, which falls this year, the OSICON, will be held from 23rd to 25th August at INCOIS, Hyderabad. Today, the Ocean Society of India is celebrating the World Ocean Day in a befitting way with several outreach programs. One of the programs is beach cleaning at selected locations of the Indian coastline in collaboration with National Center for Coastal Research, Ministry of Earth Sciences. It is well known that marine litter poses a vast and growing threat to the marine environment. The beach cleaning programs undertaken by OSI in the earlier years have been very successful in spreading the message of a clean beach and pollution-free ocean in the minds of students and general public. Keeping that experience in mind, OSI is implementing beach cleaning on a pan-India level in association with NCCR, covering 17 locations of maritime states of the vast Indian coastline on the World Ocean Day 2023. The OSI Pune chapter is an integral component of OSI. The members of Pune chapter are actively engaged in various outreach programs to popularize awareness on the ocean. We regularly arrange webinars, lectures by eminent scientists, occasionally in association with other professional bodies such as IMS Pune chapter. Currently, the OSI Pune chapter comprises of the following members. Dr. Supriyo Chakravarti, who is the chairman affiliated with Savitribai Phule Pune University. The co-chairman, Bhupendra Bahadur Singh from IITM. Dr. Hamza V, who is the secretary from IITM. Dr. Aditi Deshpande from Savitribai Phule Pune University, who is the treasurer. And we have members, Dr. Jasti Chaudhary, Aditi Modi, and Dr. KP Suraj, all from IITM. OSI Pune chapter has conducted some of the recent programs as follows. On 15th March 2023, OSI Pune chapter collaborated with IITM to co-host a talk during the workshop on role of women in weather and climate science in Pune. We honored Dr. P. Purva Sarvikar, a distinguished former scientist at IITM, for her remarkable achievements in ocean science. On March 23rd, 2023, which is the WMO Day, OSI Pune chapter celebrated by organizing a half-day workshop in collaboration with the Department of Atmospheric and Space Sciences at Savitribai Phule Pune University. The event was held at Das Seminar Hall and featured by Dr. Professor Anand Karipot at SPPU as the chief guest. He spoke about the significance of World Meteorological Day, and we hosted speakers from different aspects of marine research. The Pune chapter has also introduced a quarterly newsletter, Ocean Digest, in a bid to popularize the ocean science to common people. Scientists from IITM have regularly contributed to this newsletter. After publishing for a few years, now this newsletter is being published by the parent body. The USAT Pune chapter welcomes anyone who is interested in learning more about the ocean and its resources. And we would heartily like to welcome anyone who would be interested in joining the Pune chapter. We request you to contact any of our members that you might be in touch with. Now on to our next talk. Our next talk is by Dr. Vino Valsala, Scientist F at Indian Institute of Tropical Meteorology, Pune. Dr. Vino Valsala holds a PhD in Atmospheric and Ocean Sciences. His specializations are ocean PCO2, biogeochemical modeling and data assimilation, planetary wave dynamics and associated particle tracer trajectory pathways, application of tracer techniques to detect variability of ocean circulation, climate variability of Indian Pacific Oceans, reduced gravity layer model, quasi-geostrophic models, ocean tracer transport model, and ocean general circulation models, along with the Indonesian through flow and climate variability, numerical ocean modeling and development. His PhD thesis was on pathways and effects of Indonesian through flow water in the Indian Ocean in an ocean general circulation model in the field of atmospheric and ocean sciences from Hokkaido University in Japan. He has worked in ocean biogeochemistry modeling for robust estimates of air-sea carbon dioxide fluxes for the GOSAT project at NIES Japan from 2006 to 2011 as a postdoctoral fellow. He started his career in the Indian Institute of Tropical Meteorology as Scientist D and has published over 50 papers in the field of oceanography, atmospheric sciences, biogeochemistry, and the carbon cycle. His talk today is entitled Ocean Acidification as a Threat to Marine Living Resources. Dr. Valsala, I will request you to start your talk.
Okay, I will put up. Thank you very much for giving me an opportunity.
Thank you, Dr. Aditi, for a very nice introduction, and thank you for YSI Pune chapter for thank you for YSI Pune chapter inviting me to give a talk in this Ocean Science Day celebration, and thank you, Professor Nigam, for a very wonderful talk. We all enjoyed. We got a lot of information, and thank you so much for such a nice talk. It was truly and indeed a popular talk, but I don't think I give that intense popular talk. But I am today I'm going to present one of the other the modern day threats of the ocean ecosystem. We call it ocean acidification. So I will start my talk. So that today I'm going to talk about the ocean acidification as a threat to the marine living resources. So let us go to the talk. So today what I'm trying to do is to give some brief introduction about the ocean biogeochemistry, because ocean is a place where it supports life, as we discussed in the introductory speech today. And then comes to the ocean acidification. What actually it is talking about the ocean acidification, I'll try to introduce, and how we study this by observations and modeling of ocean biogeochemistry, and what are the observed and modeled features of the Indian Ocean acidification, and where do we stand today, and what we can do about it. So this is a kind of a mix of not very popular, but most of science talk as well in this one. So because there are many new people, new to these subjects are there. So if anybody wants to read more on such topics, so there are two interesting books available. It's written by very popular professors in this field. The Ocean Biogeochemical Dynamics by Sarmi Anton Gruber. It's a very nice book. Many of us know popular atmospheric science book and ocean science book, but not many of us probably knowing there's an interesting book has written in 2007. Widely referred in graduate schools across the world, and the Earth System Science book as Lee and Kump book also. Sorry, Lee Kump and Casting book also a very good book to study as a fundamental and a beginner's level. So let us now talk about the chemistry of the ocean. I don't know how many of you are familiar with that. So if you look at the chemical composition of the ocean, so this table nicely summarizes the elements from hydrogen, helium, lithium, beryllium, boron. This sequence you are all familiar with. This is how the elements are arranged in the periodic table, right? So the interesting point to mention here is that ocean water contain almost all elements of the periodic table in it. That is quite surprising. It is just water, but this water got dissolved so many elements of the periodic table in it already. That itself shows the ocean might have evolved over millions of years of time scale in the geological time scale, where these elements are slowly brought from the land to river to the ocean and deposited. Some are utilized, some are unutilized. We all know the ocean water is salty, but how many of you have thought, why is it salty? Why it is not sweet or sour? So that means the sodium and chlorine perhaps unutilized and left out. That is the reason perhaps the ocean water is salty. Okay. Anyway, so ocean is a collector of so many elements in it, because it's brought from the surface, from the Earth's terrain into ocean via rivers. So there is a balance achieved in the ocean water through the total change in mass is basically input minus losses. So if there is no loss, it will eventually accumulate in the water. And next I'm going to give you the periodic table arrangement of elements and the presence of those elements in the ocean. The profile, what you see is the vertical profile or vertical distribution of those elements. Almost all elements are discovered in the ocean. There may be very few highly radioactive elements which can't sustain for long term, perhaps not available, but otherwise all stable elements, including some of the radioactive elements, are present. Their presence either in the micro or macro or pico or nano, but doesn't matter. It has a vertical profile, and some of them even have interesting shapes, such as those nutrients contributing to the ecosystem or the biology of the ocean. You can see that this is the 4-kilometer depth. Each box represents a 4-kilometer depth of the ocean, and you see a profile. Okay, some of you may be familiarized with these profiles. Okay, and there are definite reasons why these profiles are built in the ocean. Okay, so it has to be through the chemistry and biological balance exist in the ocean. So that's why the ocean is a very important body where most of the interesting activities of the biological and chemical activities, it's a home to those activities. And this is a very nice picture. I don't think many of you have seen this, how the elements are available in the ocean water. Okay, so going further, so what is marine biogeochemical cycle? So it is a loop which is connecting the chemical and biological transition of material. Okay, a cycling of chemical and biological transition of material through organic matter. You can call it as a marine biogeochemical cycle. It has a biology, it has a chemistry in it, right? So this is a little bit complicated manner is shown here. So the central part is the organic matter, which synthesize the nutrients available in the ocean, and they grow in size, and then they feed on to the secondary producers, and through which the nutrients are cycled through. Okay, so these nutrients are taken up in proportionate manner. They are not all taken up. So, for example, sodium and chlorine, they are never taken up in this process, so the ocean became salty because they left out. But others, such as like nitrate and phosphate and carbon and silicate and iron, etc., are being taken up by the biology and cycled through the various processes. Some of them I can introduce to you, such as organic matter, and then it may sink, which is become the export organic matter, which undergoes disintegration or remineralization. And there are shells, for example, calcium carbonate shells. There are silicate shells. All those shells are also involved in it, and some of them will permanently sediment and deposit in the ocean floor, which we have seen in the previous talk. They explore and they find out how the history of in the Earth's evolution, right? And some of them, say for example, nitrogen cycle, which interact with the atmosphere. Atmosphere also feed nitrogen back to the ocean through fixation processes. So a lot of complicated things are going into the marine biogeochemical cycle. Now, let us simplify the process because it is easy to understand that way. The very fundamental biological cycle contains two compartments: the upper ocean, where productions are provided or supported through the presence of light and nutrients, and a subsurface place where it's an aphotic place where there is no photon or light available, where there is a return of this organic matter back into the nutrient. So these are the two compartment representation of the euphotic zone and the below zone, where the organic matter is produced in the euphotic zone by phytoplankton and then sink downward, become organic matter and remineralized by the bacteria and return back the nutrients. Again, this is brought back to surface by the ocean circulation and dynamics. This is the most simplistic cycle explanation of the marine biogeochemical cycle. Okay, and because of this, many of the nutrients profiles in the ocean takes this shape. Why? In the surface they are depleted, in the subsurface they are returned back, right? So you will see as an increase in the concentration as you go down, because it is returned back in the subsurface. So this is kind of a typical profile of a production that you see in this particular area. Okay, so this is the equation how the photosynthesis can be represented for a marine biogeochemical cycling. Okay, so going further to the marine carbon cycle. So when we talk about the biogeochemical cycle, carbon is an essential part, right? The atmospheric or any form of carbon present in the ocean, basically the dissolved carbon, will be a part of biomass production in this equation, right? So the carbon is also a part of this biogeochemical cycle. So let us see how carbon is now exchanged across the various pools of the Earth system. So there are shown here atmosphere, there is ocean, and terrestrial biosphere are shown here. So various numbers are going up and down. I'm not going into the details of it. It actually represents how much each sphere exchange the carbon in petagram carbon is written here. It is 10 to the power 15 gram carbon per year basis. It's exchanged across these various pools. Okay, so that is the arrows shown here, and which is the reason that the reason for allocating carbon in this the pyramid shape structure here. What is this shown? The storage of carbon in the various pools of the Earth system. So the atmosphere contained around 760 gigaton carbon. Atmosphere, the air contains, okay, gigaton carbon. It's a very big number, right, by weight. And ocean contained in the dissolved form 740, in the bicarbonate form 1300, and in the carbonate form much more. Sorry, in the carbonate form 1300, and the bicarbonate form much more larger carbon is dissolved in the ocean. And this is the fossil fuel 4200 gigaton carbon, which is what we are exploring today and bypassing it to the atmosphere, right? So this is the storage of carbon through this carbon cycling exists in the Earth system. Okay, so this takes a very long time scale for carbon to enter from one pool to the other pool and become a permanent storage. Okay, so it has a long time scale of transfer of carbon from one system to the other. To note, ocean takes up around here you can see that around 660 petagram carbon is respire back, and another 60 is going into photosynthesis. They are in a nice balance, but the anthropogenic components, which is 20, is going into the ocean and 17 is coming out. So that means anthropogenic carbon is going into the ocean, and that opens up the way for the acidification. Okay, so I am coming to that fact. Now, before going further, just to give you some understanding about how the carbon today's global warming, the role played by the carbon. So they can see that that the greenhouse gases are the fundamental factor for keeping Earth's surface warm. Okay, 10 or 15 degrees surface mean, and in which the carbon dioxide contributes the additional radiative forcing due to the man activity, right? Roughly 2.16 watts per meter square in the last 150 years or so, and then which having a global warming potential 1. You can see IPCC AR6 assessed that the warming contributed by the carbon alone is around 2.1 watts per meter square, which is what the number written here. Additional warming, okay, the extra warming contributed to the atmosphere. And this is, you all know the curve, which is the observed values of the carbon dioxide in the atmosphere. The rest you can read, I'm not going to further. And this is the budgeting of today's emission. Today means around roughly in the last 10-year mean that we emit 10 petagram carbon every year due to fossil fuel emissions, cement production, industrial activities, etc. 10 petagram carbon we are emitting to the air, out of which plus land use change also you emit some around 2 petagram. and the ocean takes up around 2.5 petagram into it. That's the earlier arrow I was telling you, right? The ocean takes extra carbon from the atmosphere, which is emitted by man. And that actually implies that if ocean was not taking up that carbon to its interior, the buildup of carbon in the atmosphere would have been much larger than what we see today, leads to even accelerated warming, right? It's very simple math. So this is a contribution of the ocean today taking up the more carbon into it. And now, if you see, and this is again the Keeling curve is seen, and whatever I discussed is written in the words here, which I can skip. However, this comes with a penalty, which is called the ocean acidification. So what happens when carbon dioxide dissolves in water? It is simple a reaction. Carbon dioxide plus water give carbonic acid. And this is a highly unstable form. It splits immediately and releases one hydrogen ion into the water and become bicarbonate and one H plus release. And this released H plus is what becomes water more acidic. So to explain it further, this slide, you can see that what the net reaction is that the carbon dioxide plus water, it again attack the available carbonate of the ocean, and they all converted into two bicarbonates. So what happens, this carbonate is required for shell forming organisms. If that carbonate is consumed by the carbon dioxide dissolved into the water by human emitted carbon dioxide, then it will run out of the carbonate to make these marine shells. So which will actually affect the marine ecosystem. So that is one way of ocean acidification, the potential problem. So the consumption of carbonate ions impedes the calcification. Calcification means calcium shell-bearing organisms. It cannot make calcium shells because the carbonate runs lower because of the dissolved carbon dioxide attack and chamber it in bicarbonate form. Okay, and to summarize this, I can show you this image. So what happens here? The atmospheric carbon dioxide is dissolved, and what is the reaction? So what happens? This more acidic condition will eventually work in a manner that the existing calcium carbonate will shift into the calcium and carbonate ions. So this is a two-way action. One is that it attacks the existing carbonate and chamber it into bicarbonate, as well as it gives way to the disintegration of the calcium carbonate shell. So eventually what happens is that the shell-bearing organism will feel the stress that they can't make calcium carbonate shell for their growth. Okay, so that is one problem of the ocean acidification. Then how do we study that? In IITM, we have set up a system to study this for last 10-15 years. What we have done is we model these things in computer and to study how fast the ocean is acidifying. So what you need for modeling is that a biogeochemistry model. So we have set up a biogeochemistry model in our lab, which has been modified by our own research in the past few years. And with this system, we have produced a ocean acidification data in our lab. And with that ocean acidification data, we can study how quickly the ocean is being acidified. What are the regional characteristics of the ocean acidification ongoing in the global as well as the Indian Ocean? So this, what is a biogeochemistry model? As I explained in the beginning, you need to represent the biological production. You need to represent the transition of the nutrients across the various pools of the biology. It should have a carbonate chemistry module, etc. Okay, so we try to represent them in the as minimal as possible, but accurate as we can get. And with that setup, we have developed this model, and with this model, this is a little more detail, which is not much of an interest to the today's talk. Therefore, and this is the final product we derive with this model. So this map shows the surface ocean pH of the global ocean from 1980 to 2004. And the bottom line shows the average of the global surface ocean pH, okay, from 1980 to 2004. And this is 8.1, this is 8.045. But actually, ocean is alkaline in nature, okay? So that you need to understand because of the dissolved ions left behind. The ocean is basically alkaline in nature. However, due to the excess presence of H plus due to dissolution of carbon, it turns towards the side of acidity. Okay, so 8.1 becomes now 8.045. So you can see that how nicely this trend is building up over the years. And this is directly related to the carbon which is dissolving or getting dissolved into the ocean. And this map, if you spend some time, some interesting features, you can see that the tropical or equatorial areas are more red. The red color means more acidic water. The blue color means less acidic water. So I have reversed the color to get the feeling of it. Okay. So you can see the tropical Pacific has large acidic water. And in the mid latitude, however, if you go in the North Atlantic, you find less acidic water. And there are reasons why tropical water appears more acidic in nature as compared to the high latitude water, because it's also a function of the temperature. The temperature dissolute more into H plus form. So that's why you have more H plus ionic form in the high temperature water as compared to north and mid latitude water. And Indian Ocean, you can see there are systematic buildup of acidification or acidic water in the Western Arabian Sea. This perhaps due to the upwelling of the deep carbonated water, right? And so several features you can add. Southern Ocean, very interesting thing. You can see that it's a slightly alkaline water, and then in between acidic water builds up seasonally around the Antarctica. So this is one way we can study this problem and monitor this problem. And but when we do such simulation, we should ensure our simulations are accurate as possible, so that we can build confidence and in the such data products. Right? So that's what we do further. What we have done is that just for the today's talk, I am giving a comparison of our data product with one of other product by machine learning method developed by ETH Zurich. So they have released a data from 1985 to 2018, and this gives us a good chance to compare where we stand in our reproduction of this acidification of the modern day, historic day acidification. Are we standing good with the other estimates, independent estimates? So the top panel shows the multi-year mean acidification data from our model, IITM, and the bottom panel shows those from the German effort from ETH Zurich, and they also come up with some pH data. So this is in pH unit, 7.86 to 8.18 is the scale. Now, if I compare this data for regionally, so this is the tropical Pacific. You all know what is tropical Pacific, right? 25 north, south, east to west of the Pacific. The two data products are shown here. So the message is that it is very easy to model the trends because it's anthropogenically forced. But it is difficult to capture the intermittent seasonal changes because that is more biology driven. Okay, it is not anthropogenically forced. So anthropogenic forcing means whatever we emit will go to the ocean. A portion of it is really easy to model because it is just a dissolution chemistry, nothing more than that. So what ultimately you will get is the trend agreeing between the global data product. There is no problem. They agree very well. And you can see that starting from 1985 and then all the way coming to 2018, I think, it reached the Pacific acidification in a very nice agreement between these two data products. But there are differences in the way seasonality and interannual changes are built in within the system. Going ahead with the tropical Atlantic, same story, you can see that trend is captured very nicely. And Indian Ocean. So Indian Ocean is our special interest because that's the ocean just nearby to us. So you can see there is a very nice correlation exists between the various data products. That's very encouraging. Okay, but there are differences. I will come to that in a while. This is the North Pacific, which is very wider basin, larger seasonal amplitude. There are reasons why. So you can see there is a nice agreement between these two data products. And the Atlantic, very interestingly, see that larger seasonal amplitude because colder water or the temperature excursions are larger. You can see, and then this is the South Pacific. I guess yes, it is South Pacific. You can still see interesting correlation between these two data products. This is a South Indian Ocean, I think. South Atlantic Ocean. This is South Atlantic. You still see this. So, and this is South Indian, and this is the Southern Ocean. So the Southern Ocean has a much better correlation between these two data products. And these are the seasonalities of these regions: tropical Pacific, tropical Indian, North Atlantic, South Atlantic, tropical Atlantic, North Pacific, South Indian, and Southern Ocean. So you can see that the models are suffering in the seasonal cycle, although the trend was okay, which is the challenge. Okay, unless you solve the biology and chemistry, especially biology, chemistry just follows the biology. Biology is more complicated. So many inherent loops exist within it. You can't solve it so easily. Okay, so that's the reason you have these differences in the seasonal cycle that you see. And this is still encouraging because at least they are in the same phase. Okay, they are not very out of phase. But what is troublesome is the year-to-year changes. You cannot get a good correlation among the data product, especially see the Indian Ocean. There is no correlation how the two data product agree each other. There is no agreement each other. So that is a challenge, which is what it tells that the subtle changes of the year-to-year acidification is a challenge to represent in a computer simulation. But the trends, we can do it with 99% confidence. Okay, so this is a problem one needs to solve because acidification is an ongoing problem, right? So you need to understand how the regional changes are affecting the subtle changes in the acidification from year to year. So that is a challenging problem to understand. Now going further, this is a summary of acidification from these two data products. Tropical Indian Ocean agreement that our data says that the Indian Ocean acidifying faster than what they say by 13%. And this is the global acidification resolved in our method and in their method with a moderate uncertainty. Okay, uncertainty is a problem, around 11% extra acidification we are projecting in our simulations. Now, there are also other efforts from the INCOIS. This is a simulation done by INCOIS in the ROMS model. Probably you are familiar with ROMS model, right? ROMS model also has biochemistry. And what they have done, there is one mooring in Bay of Bengal which monitor pH. This is maintained by NOAA, okay? And they have produced interesting plots of acidity data, which is this black color. And when we compare the model with the observations, and it is giving some reasonable comparison. So that means the models are reasonable to reproduce the observed pH data. And this kind of effort is going on in our neighboring institute in INCOIS. They try to simulate the pH of the system. Now let us go into a little bit the mechanistic understanding how the pHs are governed. The basic equation we should start with is that the change in the pH, in addition to the dynamics, are controlled by the temperature, dissolved inorganic carbon, alkalinity, and salinity. These are the most four important factors which changes the local pH. Why temperature important? Because of the dissolution of H+ ions depends upon the ambient temperature. Why DIC is important? Which is the presence of the dissolved carbon itself. Obviously, if you have more carbon, it's more acidity. And what is alkalinity is opposite of the acidity. How much alkaline your solution will determine how much acidity changes. And salinity, which also contribute to alkalinity further to the acidity. And these all are time-dependent equations. The total change can be decomposed into partial changes due to these components. And this is what we try to do in the Arabian Sea. For example, in this picture, you can see the component form. The temperature and the carbon component are opposite in nature. Why? Because if you have a larger temperature, your carbon water will be diluted because you do not have a supply from the deep water to the mixer layer because your temperature is warm, mixing is less. Okay, so they go in opposite direction. Always temperature component and carbon component to the pH goes opposite in direction. That is the typical property of tropical waters. Okay, so Arabian Sea and Bay of Bengal are tropical waters. And alkalinity, very mild impact, and this is 10 to the power 3 multiplied. Okay, so and this is the salinity component. And if you look at the same thing in the Bay of Bengal, again, they have an opposite tendency by temperature and dissolved carbon. They go in opposite direction, where salinity has a larger impact in the river mouths and its spreading, where it has some impact in the acidification. So we have explained the reasons why these regional features are built within the ROMS model in our paper. So now let us come to the Western Arabian Sea. Here, what we have noticed, there is an intensification in the acidification going on just due to warming of the ocean alone. I told the warming promotes release of H+. So if your global warming warms the surface ocean, it will further promote the acidification. So we have done some work in that. So what we have identified is, if you look at this west coast of this particular area, the acidification trends are quite larger than what we expect. And the reason we identified in this particular area, the ocean SST is also having a positive trend. Obviously, Indian Ocean is warming, and the SST trend itself is contributing some level of acidification. It is irrespective of the carbon what we dissolved into the ocean. The warming which is totally an independent mechanism, promotes more acidification, at least by 16%. And this is another problem, a nonlinear problem we are facing. Earlier, it was a linear problem. What you emit, get dissolved, fine. But nonlinear problem is that what you emit, increase the atmospheric radiative balance, right? More heat holding capacity, warms the ocean, and that warming of the ocean further accelerate the acidification, which is not linear to what we initially calculated. How we understand these processes and include it in our model parameterization is a critical problem. So we noticed that around additional 16% of acidification out of the 100% acidification happened by the warming of the SSD, not by the carbon alone. So this is another potential challenge in today's acidification problem. So we are working on it and how to tackle this problem properly. Now coming to the Indian Ocean biomes, what is biome? It's nothing but a homogeneous region of biological activity based on certain definition. That's the definition of a biome. We have separated Indian Ocean into various biomes, and we looked at how the acidity is developing in individual these biomes. Okay, and what we found, these biomes have a different dependency of the acidification over these biomes have different dependency on the temperature, carbon, alkalinity, and salinity. So I don't want to explain the entire plot here. What the bottom line is that in the Western Arabian Sea, the acidification and acidification is mostly contributed by the temperature and the AC. But when you come to Bay of Bengal, the alkalinity can offer a buffer. This Arabian Sea doesn't have. The reasons we explained through the riverine input, etc. So the reason is that the alkalinity buffers the Bay of Bengal acidification. So that means, is Bay of Bengal good for CDR experiment? What is CDR? It's a remedy, which I will tell you at the last. Okay, that's how the world is thinking about how to reduce this problem. So Bay of Bengal may be a good CDR place. I'll come to that in a later stage. And so dissolved inorganic carbon controls the Arabian Sea acidification. However, alkalinity buffers the Bay of Bengal acidification. Buffer means a resistance to the acidification because of its alkaline structure. That's what something we noted. Now, again, in those biomes, our model has in a good agreement with the Canadian ESM, because ESMs are much more complex in the evolution. But the trends are very nicely captured, but interannual variability, etc., is not very good in comparison. Now let us see some of the global perspective. So we have today ESMs, right? Air system model. So this paper I have seen in 2023 published Jiang et al. So what they have done, they have considered as much ESMs as possible. They averaged out all and find out the tomorrow's projection of acidification for various shared socio-economic pathways. What are socio-economic pathways? The outcome of temperature warming we expect it could be, okay, according to the level of our emissions. So we call it shared socio-economic pathways or SSP scenarios. In the SSP scenario, we're coming to the pre-industrial scenario in 1850. The model suggests this is the level of acidification or alkalinity of the water. You can see that 8.3 to 8.1, good. Pre-industrial level, okay. Then historical, which is by 2010, slightly shifting towards the acidification. And if you go by a target of SSP P1, which is highly unlikely because we already committed our warming. I don't think we will end up 2100 just warming by 2 degrees. We are already facing it, okay. So in that scenario, acidification is this much. Now the more realistic scenario, SSP 2, 3, and 5. Let us start with the worst case, SSP 5 scenario. If you are expecting 5-degree warming by 2100, this will be your acidification. The entire ocean color has changed. You can see how severe is to those calcifying organism or calcium carbonate shell-bearing organism. How they are going to survive? Their shell itself may disintegrate or corrode because of the reverse reaction when you have a higher H+ in the water, as if you are putting a shell in an acid, right? And this is how the plot changes. And this may be a most likely scenario, 3 to 7 degree warming by 2100. Okay. And this, even then, the acidification is quite high. Okay. So this is another SSP2. So if you go further with other components, this is the presence of carbonate. Why we can need carbonate? Those calcium carbonate shell-bearing organisms need carbonate to grow. This is the presence of carbonate in the pre-industrial as per the ESM projections. There's a nice amount of carbonates you can see around in this latitude, which depletes further. You can see very low, this red color means very low amount of carbonate by this scenario, which is SSP5 or SSP3. Most likely we will end up in SSP3 if we are going by today's emission criteria, right? And you see that hardly any carbonate formation in the high latitude, where most of the biology sinks the carbon. Okay, so that there is going to be a large depletion of carbonate, and this is today's historical condition of presence of carbonate. It's a nice paper, and this is something called omega, which is the saturation value of aragonite. Aragonite is a calcite form of calcium carbonate. Okay, it's aragonite and saturation of aragonite and calcite. There are two the forms of calcium carbonate. So you can see that aragonite concentration goes under saturation. This scale has level of saturation. Usually tropical water is highly saturated, so you don't have problem with the calcium carbonate shell formation. If you have under saturation, the existing shell will corrode if it falls below 1, and that's going to happen in this scenario, especially below this belt. So there can't be any calcium carbonate shell formation possible if we are pumping up the carbon to the atmosphere. This is the ESM projections. Okay, the omega values will change a lot. So these are the interesting thing, and what our interest in this laboratory is that to study the role of acidification in fisheries, for example, because that is a highly debatable item, that how the marine ecosystem is resilient to the acidification. There are large uncertainty. Laboratory study with controlled acidification says that no, they don't think to worry about the marine organisms are highly tolerant to a high level of acidification. But some other study says that no, they are not very tolerant. They immediately perish even if you change the acidification slightly. It's a highly uncertain area. Then now scientists are doing is that controlled simulation within the ocean itself. They change acidification, keeping the rest everything constant. How the species survive. Sometimes its behavior changes. And for example, in fishery, even a high acidity water, fish are moving quite swiftly. Study shows that they're highly restless, which affects their life cycle, reproduction, for example. So we are also working on how the acidity is going to affect this kind of fishery, and can we use acidity as an indicator or a prediction that future fishery in Indian coast, how it's going to change. Such activities are going on. So this is another activity we are interested in, that now we have coupled this IITM's, the extended range predictions model output. They have several ocean ensembles, okay, sitting there. So we have coupled our model with, this is one of our students did this work recently, and we are trying to see whether these prediction output can be extended with biochemistry using our system, so that we can deliver more variables such as pH and carbon fluxes, etc., which is important for the fishery, for example. And what we have seen is that our model, when we adapted to the ERPAS output, which is extended range prediction output, it reproducing the pH in the boba mooring very well. That means that product is very good. The extended range ocean ensembles are really good. They have several ensembles they run for their extended range prediction. And when we couple it, we can see that our observations are matching very well with the model predicted pH. That means we have a potential for a near real-time prediction. Reduce emission. Okay, I drive from my home, sorry, but reduce emission, that is one thing, and move to green energy. CDR, I told what is CDR is that why the ocean is alkaline today, because geologically the alkaline components arrive the ocean. We can accelerate this process, adding more alkaline components to the ocean, which will reduce the acidity. This is called as carbon detection and removal, CDR. Is an active geoengineering area going on. We may move eventually into such techniques to remove more carbon from the get away from the acidification problems. Now, highly uncertain is resilience to marine living resources, resilience of marine living resources to acidification changes. We need intense studies. This is a highly uncertain area. Take global research community; they have no clear answer. Marine living resource going to perish by acidification. No clear answer. Sometimes it shows a higher resilient structure. Sometimes it shows an extremely vulnerable structure. Okay, we need intense studies, and continued monitoring of oceanic pH is another thing, because we need to some bomb is ticking. Better we watch what is going on, right? So that's one thing. And all our efforts I shared through a website. You can go and study from it. And I again thank you for Ocean Science Society of India Pune chapter for inviting me and for sharing this information with you. Over to you, Aditi.
Thank you, Dr. Vino. Although this was a technical talk, I think the ease and energy with which Dr. Vino speaks, I've also attended some of his lectures. The entire subject is quite, seems very fascinating, and of course, the energy is quite addictive. So if we have any questions from the audience present, I think we have one.
Yes.
Yeah, Vino, this extended range prediction system.
Yeah.
I understand it's only atmosphere only model.
No, they have a coupled model. They have half of the ensemble from the GFS. The remaining have come from the CFS. And that is initialized with GODAS, runs for 30 days. And those ocean ensembles are highly useful for us. Okay. They have 8 ensemble in the old system. And in the new system, they may extend it with further higher number, or I don't know. But the old system had 8 ocean ensembles. The coupled model.
Okay. Okay.
2 questions from YouTube. I don't know whether it is, you have already answered, I guess. What is the reliability of the models you have used?
We have few observations where we can compare it, and whenever we compare, it gives the reliability. But when we compare with another data product, I already shown reliability is lost at a short time scale and interannual time scale. But the trend is easy to capture because it is quite forced linear problem.
So this question was by Dr. Satyanarayana. He is again asking why more cyclones are forming in the recent years. I think this is
that's not what
he means. The Arabian Sea has mentioned.
Yeah, Arabian Sea is asking.
Yeah, that's not what I talked about, but I'm sorry.
So I have a basic question. See, you, as I understand, there are 2 ways in which ocean acidification is increasing. So one is through extra dissolution of CO2 in the oceanic waters,
which is major.
Yes. Okay, that is major. And the other one is due to warming of the surface waters, right?
20%.
Yes.
Yeah.
So how does this ocean surface warming affect the exchange of CO2 fluxes at the surface?
That's a good question. It actually reduces the exchange. Okay. It doesn't take up further if the ocean is warming further. Because once the ocean warms further, what happens is that the dissolved carbon dioxide will have a larger movement of the molecule within the column, which exert more pressure. We call partial pressure.
Yes.
So the gaseous partial pressure in the dissolved water is larger. It can't dissolve further air. Okay. So it reduces the take-up.
Okay.
Yeah. But at the same time, when the warming happens, the dissolved carbon can split into more H+. It shifts the reaction towards the solution.
So again, this adds to the complexity.
It becomes quite non-linear problem. Yeah. There is a question.
Hello.
See, ocean fertilization means you supply the ocean where you have less micronutrients such as iron or silica. You supply artificially so that the production can be promoted, such as in the Southern Ocean, when you have a larger nutrient, but production is not high because they are suffering from micronutrients such as iron. We supply that which is called ocean fertilization. But what happens is that the production increases, synthesis increases, carbon capturing increases. But what happens to the dead material when it sinks? It immediately decomposes and it may come back. So it is not a permanent removal to the ocean floor. The effective removal is rather very limited. That's why such problems are not implemented in a global scale yet. Because these organic oozes, which are very light in weight, on its way, bacteria decomposes it and returns back as the dissolved carbon. If that water comes to surface by dynamics, immediately that excess carbon will respire back to the atmosphere. Not through biology, but by the chemistry. So it's not a very successful yet proven method. Ocean fertilization. There is a question, I'll just read it for your interest. What is the fate of, I think that's the same question, the ocean fertilization. I think somebody asked online.
I have a general question. Today we know that ocean takes about 1/3 of the antimony emitted CO2. So, as per your prediction, by the end of 2100th century, so this 1/3 number will be what?
It depends upon the scenario, SSP scenario. If SSP scenario is lightened, this 1/3 may shrink to 1/4 or 1/5, because the atmospheric carbon pressure will reduce. So ocean start emit rather than taking up. So 1/3 will not be there anymore. SSP scenario says if the emission is business as usual, this 1/3 may go to 1/2 of it. It all depends on how the scenario functions.
What is the confidence in that?
Huh?
What is the confidence in that?
Confidence. Confidence, actually, right now I did not put here. I mean, these models are tested with their uncertainty. And confidence is rather easy to achieve because it is simple chemistry. If you expose 1 liter of water in a carbon chamber, there's a definite amount it can dissolve, which is certain because it's a chemical equilibrium. So there is no uncertainty in that particular aspect. Uncertainty may come through the nonlinearity. Suppose ocean warming feedbacks to the carbon fluxes, which may be quite uncertain in all these models. Yeah.
I think Dr. Rajiv Nigam has raised his hand. Dr. Rajiv, you may unmute yourself and ask the question if you have one.
Oh, no, it's by mistake I pressed it. Thank you.
Yeah.
Look at the estimated prediction, right?
Yeah, yeah.
So from where the prediction comes from? I mean, where the model fields, the CFS or
CFS.
your biology?
CFS. I mean, see, my model runs with a physical driver. Okay, it's an offline model. OTTM is an ocean tracer transport model.
Because why I'm asking?
Yeah.
Because when you compared the acidification globally, while the model overestimated the variability in the Pacific and Atlantic, but it underestimated the variability in the Indian Ocean.
Okay.
But when it comes to comparing it with observation, so the extended range prediction was more comparable.
Yes.
That's why I'm asking whether it is coming from the system or
where is the accuracy coming from?
Yeah.
The accuracy coming from where the mooring is placed is mostly a chemically driven area. It's not biologically very active. You know that Bay of Bengal is not biologically highly exposed as Arabian Sea. Uncertainty of biology is rather less there. So there is an easy winning there. And that's why in that mooring, everything looks good. But if you have another mooring in Arabian Sea, I am sure there will be a lot of.
Yeah, that's a point.
That's a problem.
Yeah, and another point, see the underestimation of variability, what you see in the Indian Ocean region. See, is it due to the anomalous warming of the Indian Ocean? Or?
So I think you're talking about that when we compare the two data products.
Right. Yeah, OTTP.
That data product comes with machine learning gap filling. As such, Indian Ocean has no data. That is a big problem. Very few data they have to train their neural networks.
Correct.
There the uncertainty can come. Our model will already have uncertainty with modeling limitations. So we can't clearly answer. That's why
then comes to another question. When you don't have data, so how did you classify that?
Biomes.
Biomes.
Well, biomes are classified not with carbon data. That is with production data. So what we have done from the satellite chlorophyll, we have a light penetration parameterization, and looking at the phosphate profile, we can calculate the biomass production. And that will have a seasonal variance, which will tell how intense seasonally the production will change in a particular area. We demarcate such common areas and classify it as biomes. Biomes does not have a definite boundary. It's up to the person look at it. So we have 8 biomes come up with that.
Yeah, that's a very complex.
It's complex region. Yeah, it is coming from the organic matter production maps, which is modeled by looking at satellite chlorophyll and light penetration. So there is a community compensation depth, etc. involved in it. That is reuse thesis. So where we identified those biomes.
Yeah. Thank you.
What kind of input data is given to the OTTM model? Is it only
all physics, circulation, stratification, forcing all given to OTTM. That's why I take it from AirPass. There's a possibility we can take it from extended range prediction because they have already this. Okay. There are minimum 10 data we need required to run OTTM. Basically, circulation stratification forcing, mixing, etc. It parameterizes internally. It already has the scheme. See, I presented this biochemistry, but most questions come from extended range forecast. That's the reason. I mean, that's how it is. I know we function. Biochemists don't. Next, but it's very difficult problem. Biochemistry. Yeah. Biochemistry is further to the physical oceanography. It's a kind of a complicated issue. More on the CDR. CDR, yes.
Actually, I have a question. If anyone. There is a process by which alkalinity can be introduced for that CDR process. What kind of confidence do we have on how it will affect the biology, ocean biology specifically?
There can be a biologically unaffected alkaline component you can add. So like sodium, for example, they're never taken up in the biological activity. So there is no decision which one we should add, but there is a possibility that increasing the alkalinity.
And I always have this confusion about timelines. So when we are talking about ocean acidification or say any process which is going to reduce acidification in the ocean, let's say by CDR or any other process, the timeline at which ocean acidification has occurred and the timeline with which we are planning on or with where policy might be made in order to reduce that acidification. Again, how will that affect ocean biology? Would that be a good idea or bad? I mean, I just wonder how the timeline affects.
See, there are experiments about to answer your question, like fertilization. People have done modeling simulation. They fertilized at every grid point with iron. It reduced a lot of carbon in a short time scale. So it is possible, but how that will feed back to the ecosystem and comes back is a big uncertainty.
Okay, thank you so much, Dr. Vino.
Yeah.
So thank you to the audience for attending, and I will now request Bhupender Singh to propose the vote of thanks.
Good afternoon, everyone. It is my privilege to propose the vote of thanks on behalf of Ocean Society of India Pune chapter and acknowledge the contribution of each and everyone who has worked really hard to make this event a success. First of all, I would like to thank the two speakers who enlightened us with their knowledge and subject matter expertise. Without any hesitation, they agreed to deliver their talks on the occasion of World Ocean Day 2023. Dr. Nigam very nicely explained about foraminifera could be how they can be used to infer about the fate of ancient Indian towns and cities like Lothal, a city of Indus Valley civilization, the India-Sri Lanka sea link that is also known as the Adams Bridge or the Ram Setu. And in the second talk, Dr. Vino discussed about the ocean acidification, particularly the human footprint in the form of excess CO2 getting dissolved in the ocean, which makes it more and more acidic and poses a real threat to marine living resources. I believe that such informative talks would have generated a lot of interest in the research community, and in particular, it would have given us a food of thought for several interesting issues which we are usually unaware of. I thank the speakers once again on behalf of the organizing committee. I also extend my sincere thanks to Director IITM for providing logistics, financial, and all the required support at various stages for a smooth conduct of this event. Our special thanks are due to the Central OSI Committee in that we are very well supported by Dr. Rahan Tariq, Joint Secretary OSI, who led from the front in organizing this event. Our thanks are also due to the audience for participating in this event. So give yourself a huge round of applause. We further expect your cooperation in our future endeavors. Also, we would like to thank Team Seminar Halls for providing necessary support to organize this program in hybrid mode. I herewith give a special mention of the organizing committee that comprises of Dr. Supriya Chakravarti, Dr. Hamza Varikodan, Dr. Jasti Chaudhary, Dr. Aditi Deshpande, Dr. Suraj KP, Dr. Aditi Modi. Many thanks to all of them for their sincere work right from the planning to the execution of this event. Once again, I would like to thank you all for making this event successful with your contribution and blessings. Now, I would like to officially end this event. Thank you one and all, and you are invited for high tea in the adjacent hall. Thank you very much.